Hello and welcome again to problems from the book Orbital Mechanics for Engineering Students by Howard D. Curtis. I'm on to problem 1.9, and the problem 1.9 is saying a satellite of mass m is in circular orbit around the Earth, whose mass is m. The orbital radius from the center of the Earth is r. Use Newton's second law of motion together with some equations to calculate the speed v of the satellite in terms of m, r, and gravitational constant g. So what it wants us to do is use the following equations. A tangent, acceleration tangent equals the derivative of the velocity magnitude, and also an equals velocity squared divided by rho, and the other equation, which is F, the force of gravitation, which is the gravitational constant, times m1 times m2 divided by r squared. So it wants us to define these in terms of m, that's the mass of the Earth, r, and g. So it's quite straightforward. First thing we can do is change the force of gravity into mass times acceleration equals g small m big M divided by r squared. The m's cancel, and the a is actually the normal, because if you think about an orbit, the force of gravity is pulling the station inwards, so it's going that way. So that is a n, and a n is v squared over rho, which equals g m over r squared. In this case, rho is actually r, so we can cancel one of those, and so v equals square root of g m over r. That's the answer. Everything is in terms of what it asked. It wanted it in terms of mass of the Earth, the radius of the orbit, and the gravitational constant. Now we go on to 1.9. So that was 1.9. Now we're going on to 1.10. 1.10 says, if the Earth takes 365.25 days to complete its circular orbit of radius 149.6 by 10 to the 6 kilometers around the Sun, use the results of 1.9 to calculate the mass of the Sun. So the time is equal to 365.25 times 24 times 60 times 60, which equals 315,576 seconds. Distance around the Sun equals pi d, which equals 2 pi r. And when we plug in the radius of the distance to the Sun, which is there, with 2 pi, we get 9.4 by 10 to the 11 meters. And the velocity equals distance over time, which equals 29,786.8 meters per second. And if you look that up on Google, that is the velocity of the Earth going around the Sun. So that is correct. The wants us to calculate the mass of the sun. So we will use this equation here to calculate the mass of the sun. We have the velocity, which is 2,976,786.8 equals, so squared equals g me over r. We have r at 149 and we have g. So is 29786.8 squared times r divided by g equals the mass of the sun, which gives us equals 1.99 by 10 to the 30. Now that's pretty close to Google. So that is the answer. Nothing much going on here. Bit of substitution in an equation and then using that equation and a few equations of circular equations to get the mass of the sun. Thank you. Bye-bye.